Hey everybody, Mike here and welcome to the channel. Well, today we're going to do part 2 in the Ultimate Land Navigation series, and we're going to be talking about all sorts of devices to help you navigate. Here we go. Okay guys, well, what are we going to be talking about today? We have a handheld GPS device, a Garmin if you will. We have a cell phone where we can run apps, digital compasses and whatnot. We have a watch with a built-in digital compass. We have a few compasses. Now, there's a base plate compass, a mirror compass, and a lensatic compass. When it comes to all the devices, I will be talking about them individually in the video that's most appropriate. Some devices work best in one scenario and maybe another choice is better in another scenario. So all of these are going to be covered in detail. But we're going to start off by talking about what the big difference is between electronic devices, how they work, and compasses and how they work, right? So kind of in general terms what the whole idea is before we dive into detail. Let's start with the electronic devices. Now the electronic devices, they are all working via satellite. So it is a communication, actually I should say a one-way communication. They receive information from a satellite and that helps to position where you are. So let me explain that a little bit. Okay guys, so how does GPS work exactly? Well, I'm not going to make it a super scientific thing, but in short, this is what's going on. We need a planet. Okay, boom, planet Earth. We need a person holding a electronic device like a handheld GPS or a phone or an electronic watch. And this device is basically a receiver. Now, if you have a receiver, you need something or someone sending, right? Now, that's where satellites come in. We have a whole bunch of satellites. They're rotating around the globe, pass about every 12 hours, I think 11 hours and 58 minutes to be exact, but it doesn't matter. And if we have 4 satellites in reach, if you will, we are able to pinpoint where you are and in what direction you're traveling and so forth. Now, like I said, I'm not going to make it super technical, but basically what happens is the satellite sends a data package to planet Earth. It contains the exact location of the satellite when it sent it. It also contains a very accurate timestamp based on an atomic clock. So that information travels to Earth at the speed of light, so you know the difference between when it was sent and when it arrived on your device. So you can see, based on signals coming from 4 different satellites, how you can measure where you are, where you were, where you're going, and so forth. And I'll leave it at that. There are videos that are super accurate and very technical, but that's basically what's going on. Now, what's important for this video is that you heavily rely on these devices. They're electronics, right? You can drop them, break them, lose them, drop them in the river, the battery is dead, no signal on your phone, although that is not 100% necessary because your GPS would still work, but maybe the app wouldn't, and so forth and so on. The message here is this: if that device that you have dies for whatever reason, everything you did up until that point is lost. You have no history of where you came from, how you walked, in what direction, what your bearing was, and so forth. It's kind of like sitting in an airplane where the pilot decides to jump out of the parachute and you're left alone in that airplane having no idea what to do. Now, that will get you screwed fast, right? Is there a place for electronic devices? Sure, as a backup, absolutely. But I firmly believe in logging what you're doing, so writing down what your starting point was, what your bearing was, and so forth. And in this series, I will talk a lot about redundancy. So never rely on one system. I will teach you how to work with electronic devices, how to work with different compasses, but also how to navigate based on the sun, based on the moon, based on stars, based on all sorts of bushcraft tricks, right? So that in a nutshell is how GPS systems work. Okay. Okay, now that we have a better understanding of electronic devices and how GPS signals work, let's look at more traditional methods of land navigation. So we have a couple of compasses here, and we're going to look at what they have in common. And like I said, in future videos, I'm going to kind of explain in detail each one of them and where they're best suitable. All right, here we go. So, what is a compass anyway? Well, in fact, a compass is a fairly simple device. In the most simplest terms, it is a box with a needle in it that's magnetic and it's pointing north. And that is an oversimplification, obviously. Now, why is it pointing north? Well, if you have something that's magnetic and you hold it towards a piece of steel, iron, etc., it will respond, right? And the thing is, our planet Earth has a metal core, or a iron core, I should say, yeah? And because of that, if you have a magnet that can move freely, it will want to point to the north pole of that magnetic field. So the planet Earth has a huge magnetic field, and we have a north pole in the north and a south pole in the south. Simple as that, right? Now, if you have a needle that's always pointing north, then based on that information, you can kind of figure out, okay, so if I want to go south, I have to do the opposite. If I want to go to the east, I have to deviate from that bearing, let's say, by 90 degrees, and so forth and so on, right? Now, the way they did that is by saying, okay, if you have a position on Earth and we have the North Pole, then the North Pole is 0 degrees or 360 degrees. Because if you go all the way around from north being 0 degrees to east being 90 degrees to south being 180 degrees to west being 270 degrees and back to north being 360 degrees, right? So 360 and 0 is basically the same. Now, we know that it's pointing towards north, which is basically 0 degrees. Now, if you know that, you can take that information and say, all right, well, I want to go to the church tower that's 5 miles that way, right? And I can see the tip of it. So what I do is I point my needle of my compass exactly to north, and then based on that, I can say, well, wait, if I point my walking direction to the church, and the needle is pointing north, I can see how far that deviates from north. And that will give me something like maybe, I don't know, 82 degrees. So as long as my needle is pointing towards north and I keep my walking direction to 82 degrees, I should end up right at that church. That's kind of how that works, all right? Alrighty guys, now the moment you've all been waiting for. You probably thought up until now, well, this is pretty straightforward and easy, right? Well, it's not going to stay that way. And I didn't want to bring this up sooner because I didn't want to scare you guys off. But there are a couple of things that can make this quite complicated. Now, we have a compass that's pointing north. And let me tell you, I will be explaining in great detail how to navigate with a map, without a map, and all that kind of stuff, right? So don't worry about it. But what I need to explain to you is magnetic declination. Now, what is that? Well, if you look at planet Earth, you have a north that is basically straight up, right? Let's say the North Pole. Problem is, though, that the planet is slightly tilted and the magnetic field of the planet Earth is also tilted. So your your compass needle is pointing to something other than the North Pole. It has a deviation, a declination, if you will. And that's why compasses have a declination ring to compensate for that. And the thing is, if you are on a location on planet Earth, depending on where you are, you have to adjust that to the east or to the west. And depending, again, where you are, how much degrees. So if you are, let's say, pretty much parallel to where that spot is on Earth, then you have no adjustment at all. If you are very far to the left, you have to adjust it to the right and vice versa. And again, don't be too worried about that, but there you go. That's magnetic declination. So we basically have 3 types of north, and the first one is magnetic north. That's where your compass needle is pointing at, right? The second one is true north. So basically the North Pole, straight up. And the third one is map north. Now, why would map north be different? Well, imagine this. Let's say you have a spherical object like planet Earth, and you smash it flat. So you skin it and you flatten that out. What you will see is that certain cities that were very close to each other suddenly are very far apart. And there's going to be a symbol on the map that will tell you what the angle is for magnetic north, what the angle is for true north, and for map north. Now, keep in mind that when I do this series, I will be talking about working with the compass without a map and working with the compass with a map. Now, if you're not working with a map, then the magnetic declination doesn't really matter that much, because you're looking at the difference between where is north, right, whatever the compass says, and what is the angle to the church that I want to walk to, right? It's a different story when you introduce a map. So I'm going to explain both of those systems, right? And in the first following video, I will be working with a compass without a map, and then eventually we'll get to the map system as well, right? So that's what I wanted to share with you guys in this video. I know it's a long story and it might sound complicated, but I believe it absolutely necessary for you to understand exactly how these things work, to have a better understanding of what compass should I use, what should I buy, what should I not use, and so forth, right? So that's it for this video. Thank you guys for watching. If you enjoyed it, hit that thumb thing and subscribe if you haven't already. And I'll see you guys in the next one, all right? Thanks for watching. Bye.